Hello, my name is Kaylee. I'm here with Katie, Zeron, and Ellen. Our faculty mentor is Dr. Christine King, and we are working on developing a funnel-shaped balloon catheter to improve cerclage procedure efficiency. Every year, cervical insufficiency causes nearly 1.4 million preterm births. In this condition, the cervix is structurally weak and dilates prematurely. A standard treatment is cervical cerclage, which involves repositioning the protruding membrane in the uterus and suturing the cervix closed. Surgeons currently repurpose other devices, like the Foley catheter, for repositioning the membrane. However, these have sharp knobs that increase the risk of membrane rupture. And so our goal is to develop a specialized repositioning device to improve the safety of cervical cerclage and help more pregnancies reach full term.
And that takes us to the development of a product for this project. As you can see on the far left, we have a CAD design of our balloon funnel to help visualize the shape we wanted it to take. The idea is that once the front face of the balloon contacts the amniotic sac, the balloon will be inflated to surround and incorporate pressure on the amniotic sac. And this will in turn push the sac back into the uterus so that way the suturing can happen. So we're using injection molding to make this balloon, which leads to the bottom image, which is a CAD model of our mold, which is 3D printed on the right in our prototyping phase. So as you can see, we have a syringe inject that hollow space between the wax core and the 3D printed to create a silicon sheen. And once the silicon cures, we can melt the wax out to get our balloon, as you see on the right in our testing phase, where we inflate the balloon to create a consistent balloon without any sharp geometries. So as you can see on the next slide, we're trying to refine this process to make our full catheter body and balloon sheath more accurate as we try to push the amniotic sac back gently.
We'll be using a pelvic test trainer to evaluate our balloon prototypes under simulated surgical conditions. The prototype will be inserted into the trainer and will be applied to determine whether the design passes or fails under mechanical stress. And this will help us assess load tolerance and identify potential failure points. And in our future, we plan to integrate pressure sensors to quantify the forces between the balloon and the amniotic sac.
As mentioned in other slides, a large portion of our work in the moment is prototyping and creating methods of prototyping following the scientific method. Through this process, we do encounter a lot of trial and error, so our team has experienced a large learning curve. But this is very meaningful to us because we all began work in this project to contribute to the reproductive health sector while simultaneously developing our hard skills. So moving forward, when we finally do have our working prototype established, we want to do further networking and be able to pitch our demo to larger audiences. And with that, we would like to thank you all for listening to our presentation.